So here we're asked to find the value of the sum, and what I'll do is I'll start by first computing these terms. So the first term is 1 plus 1 plus a fourth, that's 2 plus a fourth, that's 9 fourth. The second term is 1 plus 1 fourth plus 1 ninth. This would be 1 plus 13 over 36 or 49 over 36. And then the third term would be 1 plus 3 square plus 4 square. So this would be 1 ninth. So the reason I'm doing this is so I can see a pattern here. 16 times 9 is 144. 144 plus 25 over 144. So what we notice here is that the tops are all squares. So I haven't taken the square root yet. So if I start with the first term, square root of that, this is the first term, and then here it's 7 6, and here it's 13 over 12. So the denominators we know would just be product of 1 times 2. So I'm looking to see if there's any structure I can give to these terms so I can then make a jump. And then this would be 3 times 4. And then the fourth term, because I think I still need a little bit more to kind of get a pattern. So this is a tedious part of this problem. 25. And this is where multiplication helps. So this is 400. That's 41. So 441 over 400 again. That square root would be 21 over 20. Again, that's 21, 4 times 5. So here, the key thing that I noticed is that the numerator is just one more than the denominator. So you notice that 13 over 12, 21 over 20. So I can rewrite these terms, the sequence, as 3 over 1 times 2, and let's see, is 7 times 2 times 3, 13 times 3 times 4. I'm retaining the original term so that I can see a pattern. And then the final term would be 2007 times 2008. And if I'm going to leave this for now. So this would be 1 times 2 plus 1 over 1 times 2. This would be 2 times 3 plus 1 over 2 times 3. And then so on and so forth. And this would be 2007 times 2008 plus 1 over this product. So essentially, if I divide each one of these terms by the denominator, it's 1 plus 1 times 2. This would be 1 plus 2 times 3, then 1 plus 3 times 4, and so on and so forth. And this would be 1 plus 2007 times 2008. So this is how I originally did. It might be a little bit tedious. There may be opportunities to cut some of the steps here, but I'll stick with this. So I have a 2007 ones here, these ones, 2007, and then I have these terms, 1 times 2, 2 times 3, and 3 times 4, all the way to 2007 times 2008. Now I do know how to deal with these because it's really 1 times n over n plus 1, which is really 1 over n minus n plus 1. So this result I kind of know. I've seen this kind of series before. So that's another advantage of having done similar problems. So this would be 1 minus half, and then half minus a third, third minus a fourth, all the way to 1 over 2007 minus 1 over 2008. So clearly these terms would all drop out, inside terms, and we have a 1 here, so that's 2008, and then minus 1 over 2008. So that gives us our answer, which is choice A. So it's a hard problem, but I think in another video I'm going to go over some of the other thoughts in terms of how we could have simplified quickly to the nth term so that it would have helped us get to the answer quickly. But for now, this in the first video, the answer is A. So here I'll review the second method of doing this problem. It's a little bit faster, but I will admit that I did not see it originally when I did this problem. So even though I was looking for it. So I'll start with the nth term. And that's 1 plus 1 over n squared plus 1 over n plus square root. So here, the denominator is the product of all the terms here, and then I have n squared plus n plus 1 squared plus 1. So this, the denominator, of course, we can take it out of the square root. That's n times n plus 1. And we have n squared plus n plus 1 squared plus 1. Now this numerator is equivalent to n times n plus 1 plus 1. Now this result may not be intuitive, and actually, even though I did kind of get to this indirectly by writing the terms, there was no easy way for me to factor this expression to get to this. I do have a method of doing it. I'm not going to go over it here, but in a separate video I'll do that. But if you use that result, that does save us a lot of time, because this becomes 1 plus 1 over n times n plus 1. And then the key thing is this is same as 1 over n minus 1 over n plus 1, because the numerator would be n plus 1 minus n, which is 1. So this is equivalent. Now, we can use that result to list our all our terms and look for a pattern. So the first term would be 1 plus 1 over 1 minus half. So then it would be 1 plus half minus a third, then 1/3 minus fourth. I'll write one more term here. So this would be 4 minus 5. And then all the way to 1 plus 1 over 2007 minus 1 over 2008. Now, if I were to add these, you'll see the inside terms will drop out. And that was the reason to do this step. And then we'll be left with 2007 of these. And then not to forget this one. And then this last term here. So we get the same answer as before, 2008 minus 1 over 2008, which is answer choice A. Here I'm going to go over the third method to find the sum. So we'll look for a pattern for these terms. Now, I've computed these terms individually, and I'm just going to write those results here. So this was, the first one was 3 over 2, and then this was 7 over, actually, yeah, 2 times 3, and then it was 3 times 4, then 13, and then we had 4 times 5, and then 21. So this was one more than the bottom. So we'll do is the summation. One term is 3 over 2. We'll try to see if you can find a pattern for the sum. One term is 3 over 2. Two terms would be 3 over 2 plus 7 over 6. So that's 3 over 3. So that's 9 over 6 plus 7 over 6. That's 16 over 6. So sum of two terms is 16 over 6. And then three terms would be 16 over 6 plus 13 over 12. So that's 32 over 12 plus 13 over 12. That's 45 over 12. So 45 over 12. Actually, I should reduce this. So 2. We'll see if that reducing helps. 15 over 4. So let's just play with these terms and see if we can relate it to that last term. So here for 1, I need to relate this to 2. So the sum 1 would be 2 minus a half. Okay, sum 2, I have to relate it to this number. So 3 minus 1/3. So actually that works. So sum 3 terms would be, this would be 4 minus 1 over 4. And yeah, indeed, that is 15 over 4. So we see this pattern. So we know that we can extend this, which means that sum of 2007 terms, notice the index, this is 2, this is 1 more, would be 2008 minus 1 over 2008. So you could take this approach too. This is probably the fastest, but it just depends that if such a pattern exists. But usually the answers will give you a clue, and I think here they do relate to these terms, so it's worth trying this. So to recap, the answer is A.